You are welcome to the Scholar Online class.
The Scholar School will establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Good day, everyone. You are welcome to the Scholar Online class. My name is Mr. Sam, and I'll be taking you chemistry. Our topic for today is chemical bonding, and today we'll be looking at the concept of chemical bonding, the types of bonding. We'll be talking about ionic or electrovalent bond, and lastly, for today, we'll be talking about covalent bond. First of all, what is chemical bonding? Chemical bonding is the attractive force holding atoms or ions together. Now, chemical bonding is a very important topic or lesson in chemistry because it shows the different bond between atoms or ions of different elements. It shows the bond that exists in a compound. For example, if I have NaCl, sodium chloride, chemical bonding helps us to understand the kind of bond that exists between sodium chloride. So, what is chemical bonding? Chemical bonding is the attractive force holding atoms or ions together. It deals with the various attractive forces joining chemical species like atoms, ions, and molecules. In 1900s, Lewis and Liebman suggested in their theory of electrovalency that atoms combine with the aid of the valence electron. That atoms combines with the aid of valence electron. This was suggested by Lewis. Now, what is valence electron? The valence electron, they play a fundamental role in chemical bonding. In the electronic configuration of an atom, the outermost shell is called the valence shell, and the electron in the valence shell is called the valence electron. For example, let's take sodium. For example, sodium with atomic number 11. I'm going to draw the electronic configuration of sodium. We have now let's count together. We have 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, in the electronic configuration, the outermost shell is referred to as the valence shell, or you call it the outermost shell, while the electron at the outermost shell is referred to as valence electron. Valence electron. Let's take a look at carbon. Another example. Let's take a look at carbon with atomic number. Carbon with atomic number what? 6. If you are to write the electronic configuration, we have 1s2, right? 2p what? 2p2, and what? We have 1s2, 2s2, and we have 2p2. Let's write the electronic configuration. Let's write the shell now. Let's draw the shell. We have 1, 2. We have 1, 2, 3, 4. This is the outermost shell, which is the valence shell. And the electron at the valence shell is what we refer to as what? Valence electrons. So valence electrons are the electrons that are the farthest away from the nucleus. This is the nucleus. This is the nucleus. Inside the nucleus, we have what we call the proton and the neutron. We have proton and neutron in the nucleus, while we have electron at the outermost shell, at the shell. Now, valence electrons are the electrons that are the farthest away from the nucleus. So as a result of this, they experience the least attraction from the nucleus. I said, the valence electrons, they are the electrons that are the farthest away from the nucleus. This is the valence electron. Valence electron. They are the farthest away from the nucleus. So they experience the least attraction from the nucleus. So with this, they have higher potential of combining or forming a bond with another element. So in chemical bonding, the valence electron, they play a very fundamental role in chemical bonding. So we'll be moving to the types of bonding. Types of bonding, we have ionic or electrovalent bond, we have covalent bond, and also we have van der Waals forces of attraction, we have metallic bonding, but today we'll be talking about ionic or electrovalent bond and then covalent bond. Now, electrovalent bond. What is electrovalent bond? An electrovalent bond is formed between two kinds of atoms having a large electronegativity difference, e.g., metals and non-metals. The electronegative difference in metals and non-metals, for example, we have sodium as an example of metals, and we have chlorine, another example of what? A non-metal. So there's a difference, a great difference in their what? In their electronegativity, which makes them able to combine together to form a bond. Now, sodium, we have 2, 8, 1. Chlorine, we have 2, 8, 7. Now, the formation of electrovalent bond involves a transfer of electrons from the less electronegative elements. When we are talking about the less electronegative elements between these two, metals and non-metals, fluorine has a higher electronegative difference than sodium. Why? Because it is a non-metal. The electronegativity of non-metals are greater than metal. We also have electropositive. So it is just like word and opposite. The electropositive difference of sodium is very great than that of chlorine. Now, let's look at the bonding between sodium and fluorine, how it involves the transfer of electrons. Before that, there is something we call octet configuration. Octet configuration. Octet configuration. When an electron completes the outermost shell, now the first shell of an electron can accommodate a maximum of 2 electrons. After that, 8 electrons, then 8 electrons. If an element is able to have a complete electron at the outermost shell, then it is said to be what? To have attained octet configuration, and by this it is said to be stable. That element is said to be stable. Now let's look at sodium and chlorine, the kind of bond that is formed between the two. Now for sodium, we have the 2 electrons. Now the 1 electron, you can fix it anywhere. but I'm fixing mine here. Now let's look at chlorine now. Now let's come together. We have 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. Then the last shell, the outermost shell, 1, 2, 3, 4, 5, 6, 7. Now let's take a look at this example. Chlorine needs how many electrons to complete the octet configuration? Just 1 electron. Chlorine needs 1 electron to be what? To become stable. Why sodium? Sodium has 1 electron at the outermost shell, which is making it not to be stable. Now, in this type of bonding or types of electrovalence bond, it involves the transfer of electron from a less electronegative element to a higher electronegative element, which means this 1 electron will be transferred from sodium to what? To chlorine, to complete its octet configuration. So 1 electron will be lost from sodium to chlorine, and so we'll be having this. So 1 electron has been what? Has been transferred from sodium to what? To chlorine, to complete its octet configuration. And by so doing, sodium has also what? Complete its what? Its octet configuration. So in electrovalence bond, it involves transfer of what? Of electron from a less electronegative element to a more higher electronegative element, which is between metal and non-metal. Another perfect example of electrovalence bond is sodium fluoride. Sodium and fluorine. The atomic number of sodium is what? Is 11. The atomic number of fluorine is what? Is 9. So let's write out the electronic configuration. We have 2, 8, and what? And 1. For fluorine, we have 2 and what? And 7. Now let's draw out the shell. The 1 electron at the outermost shell. Then for fluorine, we have this. Seven. We have 2 electrons. Then we have 7 electrons at the outermost shell. Fluorine needs just 1 electron to what? To complete its octet configuration, to make it more stable. Sodium, on the other hand, has 1 electron at the outermost shell. So there will be a loss of electron from sodium to what? To fluorine. So fluorine is going to gain 1 electron. We have this. The electron will be moving from what? From sodium to fluorine to form a what? To form a bond. So we'll be having, let me write it here. Sodium is going to be carrying a what? A positive charge, because it gives out 1 electron, while fluorine is going to be having what? A negative charge. So electrovalent bond, just as I said earlier, it involves the what? The transfer of electron from a less electronegative element to what? To higher electronegative elements. Now let's move to covalent bond. Covalent bond. Electrovalent bond, I said it involves the transfer of electron. But for covalent bond involves the what? The sharing of electron between elements of what? Of great electronegative difference. Now, covalent bond is mainly formed between non-metals. For example, we have HCl, which is what? Hydrogen chloride. HCl, H hydrogen, and the atomic number of hydrogen is what? 1. The atomic number of chlorine is what? 17. Let's write out the electronic configuration. So we have 1, and for chlorine we have 2, 8, 7. Just 1 electron. For chlorine we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the outermost shell, we have 1, 2, 3, 4, 5, 6, then 7. Now, covalent bond, I said earlier that it involves what? Sharing of electron. Now, if you take a look at this example, hydrogen has 1 electron at the outermost shell. It needs what? Just 1 electron to complete its what? Its duplet configuration, to make it stable. It needs just 1 electron to complete its what? Duplet configuration. While chlorine here has 7 electrons in the outermost shell, and it needs what? It needs 1 electron to complete its what? To complete its octet configuration. So in covalent bonding, mostly between non-metals, the 2 elements will come together to form a what? To form a bond by sharing electrons together. This is it. This will come with this together. So we have this. So now, when hydrogen and chlorine atoms combine together to form a covalent bond, this is what we have. This is hydrogen, and this is chlorine. By so doing, hydrogen has been able to what? To form its duplet configuration, while chlorine has also been what? Been able to what? To complete its octet configuration. Let's count together. We have 1, 2, 3, 4, 5, 6, 7, 8 for chlorine. While for hydrogen, we have 1, 2. Balanced. So another perfect example for covalent bond is we have CH4. CH4. Carbon and 4 molecules of hydrogen. Hydrogen, the atomic number of hydrogen is what? 1. Atomic number of carbon is what? 6. Let's write out the electronic configuration. We have 2, and then we have what? We have 4. For hydrogen, we have 1. But don't forget that this hydrogen is what? 4 molecules of hydrogen. Now let's draw out the shell. 1, 2. 1, 2, 3, 4. While for hydrogen, we have just one. 4 molecules times what? 4. Now, if carbon and hydrogen combines together to form a covalent bond, we will be having 2, 3, 4. This is for carbon. Now, this is the bonding. One molecules of hydrogen, another molecules of hydrogen, another molecule of hydrogen making 2, another molecules of hydrogen making 3, another molecules of hydrogen making 4. So covalent bonding has to do with what? The sharing of electrons, while electrovalent bond has to do with what? The transfer of electrons between an element of lesser electronegative difference to higher electronegativity. So today we've been able to talk about the concept of chemical bonding, and I said chemical bonding is the attractive force holding atoms or ions together. And then I said the valence electron, they plays an important role in what? In chemical bonding. And I talked about the valence electron as the electron at the outermost shell of the what? Of an element. And I used sodium as an example. That sodium has what? It has one electron at the outermost shell. This one electron is referred to as what? Valence electron. And I also talk about valence shell. I said the valence shell is the shell at the outermost what? At the outermost configuration that is showing the what? Or displaying the valence electron. And we also talk about the types of bonding. And I said we have electrovalent bond and we have covalent bond, which are the two main germane bonds that we have in chemistry. We also have van der Waals forces of attraction. We have hydrogen bond. We have metallic bond. We have London dipole bond, so on and so forth. And I talk about electrovalent bond, and I said electrovalent bond is formed between two kinds of atoms having a large electronegativity difference. Example, between metals and non-metals. And I said the formation involves a transfer of electron from the what? From the less electronegative atom, which is metal, to the more electronegative atom, which is non-metal. And I gave a perfect example of sodium chloride, NaCl. And I said sodium has 1 electron at the outermost shell, while chlorine has what? 7 electrons at the outermost shell. And I said for chlorine to complete its octet configuration, it has to what? Receive an electron from what? From sodium. And I said octet configuration is attained when electron is able to complete the number of electrons it is supposed or intended to carry. Now I said the first shell is capable of carrying 2 electrons, while the second shell 8 electrons, the third shell 8 electrons, and so on and so forth, 8 electrons. Now I talked about the covalent bond, and I said covalent bond involves the what? The transfer, the complete transfer, sharing of electrons. Electrovalent bond involves complete transfer of electrons from less electronegative elements to what? To more electronegative elements. While covalent bond involves the what? The sharing of electrons between 2 elements. And I gave a perfect example of HCl, hydrogen chloride, HCl. And I showed how hydrogen and chlorine come together to form a bond which is known as covalent bond. I also gave an example of CH4, which is called methane, an organic compound. I showed the formation between chlorine and 4 molecules of hydrogen. So in our next class, we'll be talking more and discussing more on other types of bonding that is involved in what? In chemistry. So see you in our next class. And if you are just joining us for the first time, you are welcome to the Scholar Online class. Don't forget to subscribe to our channel and make sure you click on the notification button so you can receive a notification when we drop a new video. Thank you very much.